Hello guys, I welcome you all. So in this session we are going to start up with circular cube. So it is a very interesting topic friends, please don't miss this, right? So we discussed so far about Q data structures. So why we want to see this circular cube and what is its benefits. So all those things we are going to discuss here, and how it is being operated, that is what all the operations that is being performed in this circular cube, all those things we are going to see here, right? So if any new viewer is present here, I request you all to please subscribe this channel so that it will be a great motivation for all of us, right? So friends, these are all some of the important points of a circular cube. So why we are using this is being written over here, right? So what is a circular cube? So the circular cube is used, that is it has been found in order to overcome the disadvantages of cube. So now before discussing these points, I must have to tell you what is the problem in Q data structure. Suppose if any viewers who didn't watch my Q data structure classes, I request you to go and watch and come over here so that you can be able to follow this session. Okay friends, so now we will go for to find what is the problem that is being present in the Q data structure. Okay, so now this is the diagram of a Q data structure. So now I am going to insert the elements. So now please think and tell me what all the pointers, that is how many number of pointers we are using in Q data structure. So we are using 2 pointers, isn't it? Front and rear. So what is a front pointer? So the front pointer is going to delete the elements and it is going to increment one by one. So what is a rear pointer? So in the place of the rear pointer, we are going to insert the elements and increment that pointer after inserting. So this is the basic operation of a Q data structure. While following that operation here, see what is going to happen. So now as there are no elements that is being present in this Q data structure, initially front and rear value will be -1. Friends, is it possible for you to remember? So initially the front pointer and rear pointer will be -1 because there are no elements, right? So first we must have to bring the pointer to the 0th location and then only I must have to insert the elements. So that is the thing we were being discussing in the last class, right? So now this is a Q data structure. I am going to use array representation for storing the elements. So here if you see, there are no elements present in the data structure. Now I am going to start inserting the element. So initially front pointer will be here and rear pointer will be here. Now I am going to insert. For example, let me insert some character. So A. Okay. So now what I will do? I will be incrementing my rear pointer for adding the successive values. Okay. So let me erase this. So my rear pointer will be here. I will be adding the element. So increment the rear pointer C. Now again increment the rear pointer, it is D. Then once again you increment the rear pointer, it is E. So now what is happening? I have added all the elements by incrementing the rear pointer. Finally the rear pointer will be pointing to this location. So front is here, rear is here. So now I am going to perform the deletion operation. So what is the representation of Q data structure? So it uses the format of first in first out method. That is, what all the elements that is coming in the first, it will be deleted accordingly. So that we are going to do it over here. Then another thing is that friends, if they have asked you like this, instead of first in first out, they will give you as last in first out. Last in last out. Okay. So instead of first in first out, in order to make a confusion, they will ask in the question as last in last out method. If it is given as last in last out method, it is also means that we are using Q data structure. So what is last in last out? The element that is entering at the last will be deleted at the last. Okay, so both are having the same meaning. Is it? Indirectly, what is the meaning? The first element only will be deleted, isn't it? So please make a note of it. Last in last out method. For stack, what you are going to do? What is the representation of stack? So stack is last in first out method. right? So for stack is last in first out method, they may give as first in last out. Okay, so this is first in last out means also it is a stack data structure implementation. Last in last out also means that it is a queue data structure implementation. So please make a note of it. Okay. So now we will go for the deletion operation of a queue data structure, right? So how I am going to delete the element? So from the front only I will be deleting, I will be incrementing the pointer to point the next first element. Okay, so now A is deleted and my front pointer will be pointing here. Now once again B is deleted and front pointer is pointing here. Next C is deleted and my front pointer will be pointing here. Next D will be also deleted and my front pointer is going to point here. Okay, so now after performing these deletion operations, suddenly I want to insert one element inside the queue. Can I insert the element? You please see, there are spaces present. There is 0, 1, 2, 3. All these spaces are empty. But if I try to insert the element, I cannot do in queue data structure because the rear pointer is pointing to this last index value. So there are no way for bringing this pointer to this location. Because from here I can insert the element, isn't it? All these spaces are getting wasted, right? So how to use the spaces? Because there is no way for incrementing the rear pointer in queue data structure. So what can I do? For example, the solution may be I can make this rear pointer to start pointing to this location. Isn't it? Can I do? So once again what will happen? So here my values will be inserted. So this will be my first element. For example, W will be inserted, isn't it? Then X, Y, like this. There are 3 new elements that is being present in queue data structure. Okay, so now what will be the pointer for Y? So rear will be pointing to this last element and now E will be your first element. Can I do in queue data structure? I cannot do. In order to make this possible, we are going for circular queue implementation. In circular queue implementation, once after the rear pointer is reaching this position, in order to make that rear pointer to once again point to this location, like this. Okay, so what we are doing is, we are implementing it by using circular queue. Okay, so after all the elements are filled, that is after the rear pointer has reached the last location, in order to make use of these empty spaces, once again we are making the rear pointer to point to the first element and successively we are going to insert the elements. Okay friends, are you all clear? Right. So this is called as a circular queue. Why it is called as circular? From last, once again we are making the rear pointer to point to this first index value. So we call it as a circle. Okay, even front pointer also you see. After deleting this element, once again we are making the front pointer also to point to this location because after E, W is your first element. Okay, understand the diagram. Okay, then you will be able to follow. Okay friends, so we are overcoming the empty spaces of a queue data structure by using an implementation of circular queue. So friends, I think so up to you, you will be clear with the manual operation, the internal operation of a queue data structure. Just we are going to form a cycle to navigate the pointers from last to once again point to the first index. So now we are going to see how we are going to deal with it by using certain conditions. So now this is an empty circular queue data structure. So like this also we can represent the way we are using the pointers, we can identify that it is a circular queue, right? So now initially in this data structure there are no elements. So what is the size of this circular queue data structure? It is 5. So the size of this data structure is 6. So that is I can insert 6 number of elements in this array. So another thing I just forgot, friends. So the another name for Q, circular Q, is ring buffer. Okay, just now I draw a diagram, isn't it? I drew a diagram where I represented this Q data structure in a circular format. So the another name for circular Q data structure is ring buffer. So please make a note of it. So they may ask in MCQ. So now we are going to start inserting the elements. So now initially there are no elements. So what will be the values of front and rear pointer? So the values of front and rear pointer will be -1. Right? So this is the first condition. So what we are going to do, since there are no element, so Q will be empty. Okay, so if front and rear pointer is equal to -1, the Q is empty. Isn't it? Now it is empty. Okay, so now we are going to start insert the elements using circular Q format. So now we are going to make the rear pointers and front pointers to come inside the data structure. Okay, so now like this I am making. Okay, so first I am inserting the value as A. So since the A is only one element that is being present, okay, so A is the first element and A is also the last element. Okay, right? So now I am going to increment my rear pointer to insert another one element. So B, rear is pointing here. Now increment the rear pointer and C is pointing here. Now increment the rear pointer and D is inserted. Now increment the rear pointer and E is inserted. Then finally rear will be pointing to this location. Right. Okay. So now another one element is coming. For example, G. So another element G is coming. If we want to insert this element, is it possible? Please tell me whether it is possible. No, because this circular Q data structure is full. Okay, how we can identify whether the data structure is full or not? By seeing through naked eye, you are telling that all the elements are being filled. So I cannot insert like that, we are telling. So now it is represented internally, isn't it? So I must have to check each and every time whether the Q is full or not. So how can I check? So the condition for the Q to be full is, see, rear, if it is pointing to the last index value, I cannot insert any more elements. And front pointer is having the element in the 0th index. Okay, see, rear is having the element or it is pointing to the last index value element. Okay, and the front pointer is having the element in the 0th index. Okay, then what is the meaning? The elements that is present in between front and rear are all there. So I cannot able to insert any more elements, isn't it? So if front is equal to 0 and rear is equal to 5, if front is equal to 0 and rear is equal to 5, I can tell that Q is full. I cannot able to insert any more elements. I cannot insert any more elements, isn't it? So this is the condition for checking whether the Q is full or not, right? So please make a note of it. So I can write as F is equal to 0 and R is equal to N. N minus 1. Okay, so F is equal to 0 and R is equal to N minus 1. What is N value? N value is 6. Okay, so 6 minus 1 only, I will be getting the answer as 5. So if F is equal to 0 and R is equal to N minus 1, we can tell that it is full. I cannot insert any more elements, right? So another condition for checking whether it is full or not is, indirectly we are going to represent it by using the formula. Okay, so I am going to write the what is that formula. So the formula is front. Students, very important formula, they may ask even in problem. Okay, so front is equal to real plus 1 mod n. So this is one of the formula to check whether this condition is full, whether the Q is full. So now shall I substitute here? So now you tell me what is the value of real? So the value of real is 5. So 5 plus 1. Okay. So modulus of n. So what is n value? So n value is 6. So what will be the answer? So the modulo is we are going to find the remainder. So 6 divided by 6, you will be getting the answer as 0. So what is the value of 0? It is front. So front is equal to 0. Okay. So the meaning is whether if rear is equal to n only, I am getting the answer as front equal to 0. So this whole condition, front equal to 0 and rear equal to n minus 1, all lies in this one formula. All are lying in this one formula. We can use either this condition or you can use this one condition. Okay, so this condition is used for checking whether the circular cube is full. Either you can use this condition. As both the conditions are merged together in one formula, I can use this. Can you understand? So this is a very important formula. Please make a note of it. Friends, are you all clear how we are checking whether the circular cube is full or not? Right? So friends, in this session we discussed about the introduction of circular cube and how its manual operations are done and what are the conditions for inserting the elements. Right? So in the next video we are going to discuss how to delete the elements and how to make the rear pointer on the front pointer to point back to the previous index value. So all those things we are going to cover it in the next session. So the next session will be more interesting. So please watch my video.